This is K Anand Goud from Civil Engineering Department, Institute of Aeronautical Engineering. So in last session we have discussed about the different types of cement, right? So this is the continuation of that topic. So in this session also we are going to discuss about remaining types of cements. So coming to the third type of cement, rapid hardening cement. So the name itself suggests that rapid hardening cement. That means the hardening process will be very fast when you compare with the previous two cements. Okay, so here coming to the properties, it contains large proportions of lime than OPC. Okay, when you compare with the previous cements, OPC, ordinary Portland cement and quick setting cement, so here the lime content of the rapid hardening cement is higher than the OPC. Okay, and it burns at high temperatures. Okay, so for burning this type of temperature, we need to apply very high temperatures compared to ordinary Portland cement and quick setting cement. And next, finer than OPC. Okay, the fineness of the cement particles will be somewhat small compared to the OPC. And next, attains high strength, because here the hardening of the particular cement is very rapid. So within that means within short time it is going to gain high amount of strength when you compare with the ordinary Portland cement. So here attains high strength. That means within short time it is going to achieve more strength. Okay, so I will tell you the strength of the hardening cement. So here 1 day strength of the RHC, that means rapid hardening cement, is equals to the 3 day strength of OPC. That means for OPC, if you take OPC strength after 3 days or else after 7 days, the strength will be around 17.5 Newton per mm square. Okay, but here that strength, okay, that 17.5 strength will be achieved in 1 day itself. Okay, so that is what the benefit of this particular rapid hardening cement. Okay, and next, it has high heat of hydration and high shrinkage coefficient. Okay, so the heat of hydration is also very, very high. That means it is going to generate, or else it is going to evaluate more heat. Okay, and next, costlier than OPC. Okay, the economy, if you compare with the economy also, then the cost of this particular rapid hardening cement is also very high. Okay, and next properties, coming to the properties of rapid hardening cement. So the initial setting time. Okay, initial setting time will be 30 minutes. Okay, that is the minimum time which is going to take for setting of cement paste. Okay, so that is the initial setting time. And next, final setting time is 10 hours maximum. It may take around 6 to 10 hours now. Okay, so here this is the maximum time for final setting time. Okay, and next, compressive strength of this particular rapid hardening cement is for 1 day. Okay, after 1 day, if you check the strength of the cement, compressive strength of the cement, then the strength will be around 16 Newton per meter square. Okay, so this is the strength of the rapid hardening cement after 1 day. Okay, and next, 3 days strength of the rapid hardening cement is 27.5. Okay, so almost it is almost equals to the 28 days strength of OPC, that is ordinary Portland cement. Okay, so coming to the uses of rapid hardening cement, so it is used when the load is applied in a short period of time. That means here the name itself suggesting that rapid hardening cement. That means within short time we are going to get the strength, ultimate strength, right? So whenever you are going to apply the loads on the member or its component within short time, there we are going to use this particular type of cement. Okay, and next, it does not require more curing time. Okay, for curing also it is not going to take much time. That means curing is nothing but application of water content to process the hydration process, right? So here the curing time is also very, very less. And next, suitable for repairs of bridges and roads. Okay, whenever you are going to repair any roads, within short time you are going to apply the loads, right, by movement of loads, by movement of vehicles. So here we can use this type of rapid hardening cement. Okay, and coming to the next type of cement, low heat cement. Okay, so here low heat cement is nothing but it is going to evolve, or else it is going to generate less amount of heat when you compare with the other type of cement. Okay, the heat evolution is less. Okay, and next, to limit the heat of hydration. That means here in this type of cement we are getting very less amount of heat, right? So what is going to affect the less heat here? Okay, so by decreasing some amount of chemicals, okay, by decreasing the chemicals or else by changing the chemical composition of cement, we are going to produce this particular low heat cement, right? So here, by reducing the tricalcium aluminate, okay, we are going to reduce the tricalcium aluminate up to 5%. Normally it is around 6 to 11%. Okay, in normal OPC cement, the percentage of tricalcium aluminate is around 6 to 11%. But here we are going to reduce that particular tricalcium aluminate to 5%. Okay, and next, high percentage of dicalcium silicate. Okay, high percentage of tricalcium silicate and tetracalcium aluminoferrate is added. Okay, by reducing the tricalcium aluminate and by increasing the dicalcium silicate and tetracalcium aluminoferrate, we are going to change the chemical composition, and with the change in chemical composition here, we are getting very less amount of heat. Okay, and next, the heat of hydration should not be more than. Okay, so in this particular type of cement, the heat will be limited to particular value, right? So here, after 7 days, okay, after 7 days, if you check the heat evaluation from this particular type of cement, that will be around 272 joules per gram. Okay, and next, after 28 days, okay, after 28 days, if you check the heat evaluation, then it will be around 314 joules per gram. That means 314 joules per gram. Okay, so rate of development of strength is slow, but the ultimate strength is same as OPC. So here, if you compare with the ordinary Portland cement and low heat cement, the development of strength, that means the gaining of strength with time, will be very less. Okay, in vacuum, I mean in low heat cement. But if you compare with the OPC cement, in that particular cement, the development of strength will be moderate. Okay, it is not high and it is not low. But in this particular low heat cement, the rate of development of this particular strength will be slow. Okay, and next one. And again, if you compare this particular ultimate strength, okay, initially the development of strength will be slow, but the ultimate strength after 28 days or else after curing period, after complete curing period, the ultimate strength will be almost equals to the ordinary Portland cement here. Okay. And next, coming to the properties here, less heat is evolved. Okay, this is one of the property we have to consider while manufacturing the low heat cement. And next one is initial setting time. So it should not be less than 60 minutes. Okay, whenever you are preparing this particular low heat cement, we have to add the chemicals such that we should get this initial setting time less than 60 minutes. Okay, and next, final setting time is, it should not be more than 600 minutes. That means 10 hours. Okay. So these are the few properties of low heat cement here. Okay, and next, coming to the uses of low heat cement, it is suitable for large mass concrete. Okay, here large mass concrete is nothing but this particular large amount of concreting we are going to use in the foundations. Okay, in foundations or else dams. Okay, so in this particular large structures, we are going to use high amount of concrete. So whenever you are going to use excess amount of concrete, okay, there we are going to use high amount of cement, right? So if you use more cement in any construction, then it is going to evaluate, or else it is going to generate more amount of heat. So in that particular structures, if you want to get less heat, then we can use this low heat cement, okay, to reduce the amount of heat generated from the particular structures. Okay, and coming to the next type of cement here, high-alumina cement. Okay, so here the alumina content will be more. Okay, so this particular high-alumina content will be changing the properties of cement that we can discuss now. Okay, so the first point is, this is manufactured by fusing or calcining the bauxite material. Okay, so this particular cement is manufactured by using fusing of particular bauxite. Okay, bauxite is nothing but it is an aluminum ore. Okay, which we are going to get naturally on the earth. Okay, and we are going to use limestone also. Okay, for burning of this particular cement by using bauxite and limestone. Okay, we are going to use both chemicals, that is bauxite and limestone. Okay, by burning these materials, we are going to get the high alumina cement. Okay, so coming to the chemical composition of this particular high alumina cement, so we have to maintain proper proportions of each and every element. So coming to the bauxite chemical composition, this will be around 40%. Okay, out of 100% of cement, we are going to use bauxite around 40%. Okay, and next 40% of lime. Okay, out of 100%, 40% bauxite and 40% is lime. Okay, and next remaining 15% is iron oxides. Okay, remaining 15% iron oxides and remaining 5% is silica and magnesium. Okay, so these are the different chemicals which we are going to use for manufacturing of high alumina cement. Okay, so 40% bauxite and 40% lime and 15% of iron oxides, and remaining 5% will be silica and magnesium. Okay, so by maintaining these particular compositions, we have to prepare the high alumina content. And next, alumina content should not be less than 32%. Okay, in earlier point where I have mentioned that percentage of 40%, right, bauxite percentage, but here we can use up to 32%. Like we can limit the percentage up to 32%. Okay, so we should not use less than 32%. Okay, in any circumstance we can use up to 32 to 40% of bauxite percentage. Okay, this is about alumina content basic points. And next, coming to the properties of high alumina content cement. So here the first one is high early strength. Okay, so that means here it is going to gain, or else the development of strength will be high in the early days. Okay, after casting the cement components or else concrete components, the strength achieved in early days will be high compared to the previous cements. Okay, so coming to the exact strength of the particular high alumina cement, 1 day strength. Okay, 1 day strength of this particular high alumina cement is equals to the 28 day strength of OPC. Okay, so almost in OPC we are going to get 17.5 Newton per meter square, right? So this is the ultimate strength we are going to get in OPC, but that strength will be achieved in single day. Okay, that is around 30 Newton per mm square. Okay, so this is the strength achieved by high alumina cement within 1 day. Okay, and coming to the 3 days strength. Okay, if you check the compressive strength after 3 days, that will be around 35 Newton per mm square. Okay, so this is the strength achieved by the high alumina cement after 1 day and after 3 days. Okay, that is why we are going to call it as a high early strength cement. Okay, and next, heat of hydration is more during the setting and hardening. Okay, because it is going to achieve the strength within short time, right? So if the strength is achieved within very short time, then the hydration process will be very rapid. Okay, so if the hydration process is very rapid, then the heat of hydration is also very high. Okay, because it has to set and it has to gain some strength within short time, right? So that is why the heat of hydration is also very high for high alumina cement. Okay, next, coming to the next property, initial setting time is more than 30 minutes, even up to 2 hours. Okay, the initial setting time for this particular high alumina cement is 30 minutes to 2 hours. Okay, we cannot define exact time, but it is around 30 minutes to 2 hours. Okay, it may set within this particular range. Okay, and next, final setting time should not be less than 600 minutes. Okay, so it should be more than 600 minutes mark. Okay, whenever you are going to check the final setting time of high alumina cement, the final setting time should not be less than 600 minutes. That means it should be greater than 600 minutes. Okay, around 10 hours. Okay, next one, expansion of cement should not be more than 5 millimeters. Okay, the expansion, after checking the expansion of the cement also, it should be limited to 5 millimeters. Okay, and next, resist action of acids. Okay, there is resistance to chemical solutions like hydrochloric acid. Okay, or else from rains also we are going to get some other chemicals like sulfur. Okay, so the resistance to these particular acids will be more for this particular high alumina cement. Okay, and next, coming to the uses of this high alumina cement, due to high evaluation of heat. Okay, due to high evaluation of heat, very much useful in frost and snow affected areas. That means it is going to generate high amount of heat, right? So whenever the temperature is low, okay, whenever the climatic conditions are very cold, then in that particular conditions we can use this high alumina cement because it is going to evaluate high heats. Okay, and next, coming to the next point, since its initial setting time is more, it can be handed and used in construction easily. Okay, for this particular type of cement, the initial setting time is very high, that is 30 minutes to 2 hours, right? So here, due to this particular time, we can use this particular cement, or else we can handle this particular type of cement very easily. That means we can take more time for placing and mixing of cement. Okay, sometimes you need very high time for mixing or else for placing the cement paste in a particular component. So in that particular type of situations, we can use this high alumina cement. Okay, And next, used in precasting. Okay, whenever you are going to construct precasted members. Okay, like if you observe the metro construction, there every component is used from the precasting only. So if you want to construct, or else if you want to cast precasting elements, okay, then we can use high alumina cement. Okay, and next, should not be used where the temperature is more than 18 degrees Celsius. That means already from this particular cement we are getting high heat, right? So if you use this particular cement in high temperature areas, then the heat which is generated from the cement and the outside temperature both are mixing, and it is going to affect the performance of the cement or concrete. So that is why we have to use this particular cement in a low temperature areas. Okay, that is below 1800 degrees Celsius. Okay, and next, coming to the next type of cement, blast furnace slag cement. So here, blast furnace slag is nothing but it is a waste product. Okay, it is a waste product which is obtained during the manufacturing of iron. Okay, whenever you are going to iron, from iron ores we are going to extract different metals, right? So while extracting those metals, we are getting some types of waste. Okay, that waste will be useful for the cement as a cementing material, because that particular waste material which is collected from the manufacturing of metal will have the composition same as the cement. Okay, so it contains basic elements of cement like lime, silica, and aluminium. Okay, so based upon these three elements, the cementing property will be increased. Okay, that is why we are going to use that waste product in a cementing material. Okay, as a cementing material. Okay, so it is having the contents of lime, silica, and aluminum. So these are the major chemicals which are present in the cement also. So that is why we are going to use this particular blast furnace slag as a cementing material. Cementing material is nothing but the material which is having the properties of cement. That means binding properties. Okay. Next, slag is crushed and mixed with a cement clinker. Okay, whatever the waste material we are going to get during the manufacturing of during the manufacturing of iron, that will be called as a slag. Okay, that slag will be mixed at the time of grinding the clinker material. Okay, so you know the clinker material, right? So clinker material will be in a round particles, some round shaped particles. So whenever you are going to grind this particular clinker materials, at that time we are going to add this slag material. Okay, so after that we are going to get the powdered material. Okay, that is called as a blast furnace slag cement. Okay, now coming to the proportions. Okay, so here how much quantity we can add. Okay, that slag content we can add in a cement, manufacturing of cement, right? So that proportion is slag. Coming to the slag percentage, okay, it is around 65%. Okay, we have to add 65%. Okay, and next, coming to the cement percentage, it is 35%. Okay, we are not going to use total 100% of slag, but we can add up to 65% of slag material, and remaining 35% will be your cement material. Okay, and next, coming to the properties, strength in early days is less. Okay, the development of strength in early days, that is, we are going to check the strength for 1 day, 3 days, and 7 days, and 28 days, right? So within short time, that means within 3 days or 7 days, the development of strength will be less compared to the previous types of cement, that is ordinary Portland cement, quick setting cement, and high alumina cement. Okay, and coming to the uses of blast furnace slag cement, it is used in massive works like dams and foundations. Okay, for the construction of dams and foundation, we are going to use this type of cement now. Okay, and coming to the next type of cement, Portland pozzolana cement. Okay, so here the pozzolana is nothing but it is a volcanic powder. Okay, after volcanic eruptions, we are getting some black material, right? Gray color material. So that material is called as a pozzolana here. Okay, it is resembles like a surki. Surki is nothing but burnt brick. Okay, after manufacturing of brick, you are going to burn the bricks, right? So when you burn the brick, that color will be around, it like a maroon color, okay, brown color, or else red, orange color. Okay, so this particular pozzolana is also looks like a surki. Okay, and next, coming to the proportions of Portland pozzolana cement, it is around the pozzolana which is collected from the volcanic eruptions, that will be around 10 to 30%. Okay, and next, cement percentage is around 70 to 90%. Okay, so don't confuse between the blast furnace slag cement percentage and Portland pozzolana percentage. Okay, here pozzolana percentage around 10 to 30% only. Okay, and remaining 70% will be around, will be cement material. Okay, and coming to the properties of Portland pozzolana cement, first one is development of strength is slow. Okay, as we have discussed for the blast furnace slag cement, here also the development of strength in early days is very slow. Okay, and higher resistance to chemical action, because this particular pozzolana is getting off. We are going to get this particular pozzolana after burning the, after volcanic eruption, right? Volcanic eruption is nothing but there the burning process will be very high. Okay, so because of that particular reason, the resistance to chemical action will be very high. Okay, and next, improves workability. Okay, the workability of the cement will be high. That means here workability is nothing but ease of mixing or placing. Okay, or else compaction will be very easily done. Okay, so the workability will be improved if you use this Portland pozzolana cement, because the particle size will be very small. Okay, and next, it has got water tightness and fire resistant qualities. Okay, water tightness is also very high, and fire resistance quality is also high compared to the previous types of cement, because this particular cement will be getting after burning at high temperatures, very high temperatures. Okay, and next, it is cheaper. Okay, because this is the material which is obtained after volcanic eruption. Okay, we are not going to spend any money over, for collecting this particular pozzolana. So the cost is also very, very high, and we are not going to use any raw materials for preparing this particular pozzolana cement. Okay, that is why the cost of this particular cement is very low. Okay, and next, it resists action of sulfate. Okay, sulfate attack is also resisted very carefully by using this particular pozzolana cement. Okay, and next, possess higher tensile strength. So whenever you are going to burn any material at high temperatures, that will be having very high tensile strength. Okay, so likewise, this particular material is also having very high temperature compared to previous cements. And next, it offers great resistance to expansion. Okay, expansion is also very less compared to ordinary Portland cement. Okay, so the resistance to expansion is very less. That is why we can use this particular cement in a specific conditions. Okay, so thank you.
Like, share and subscribe. Hit the bell icon for more updates.